Do you feel the vibes?
All right. Okay, so we're going to do completing the square for this, right? So first, we have to divide everything by a. So we get x squared, don't write too big because we need a lot of space, plus b over ax plus c over a is equal to 0. Now, we need to bring the last term over to the other side, remember? So it's going to be x squared plus b over ax plus a number equals negative c over a plus a number. So now, to get that number, it's going to be half of b over a squared, right? So that is going to be b over 2a squared. We're just going to leave it like that for the time being. Okay? So here too, b over 2a squared. Cool? Okay, so now it's easy to factor this. So we take the square of the first plus the square of the second, the square root squared, right? Equal to, okay, so now we have to add this. So it's going to be negative c over a plus b squared over 4a squared. I just squared it. I haven't done any adding yet. Okay, I need to add this, right? So basically this first fraction, I need to multiply by 4a. So let's see what I have now. Let's just simplify. X plus b over 2a squared is equal to, okay, here I have negative 4ac over 4a squared plus b squared over 4a squared, right? Okay, can I take a square root of both sides? Yeah. Okay. Oh. Yeah. Okay. Huh? Oh. Yeah, well, I'm taking the square root of the whole right side. Oh, so you just leave that. Yeah. So look at what's happening. Over here, I get x plus b over 2a is equal to, plus or minus. Okay, so you know what? Before I do that, can I just say this is the square root of, let me just combine it under one fraction first. Can I combine it in one fraction? What will the denominator be here? 4a squared. And then in the numerator, I don't like, can I just switch the order? Can I write b squared first and then the negative 4ac? Oh my God. Oh my God. So now this is x plus b over 2a is equal to plus or minus, and now let's split this. In the numerator, I have the square root of b squared minus 4ac. What do I get in the denominator? 2a. Oh my God. And then, so let's just solve for x. X equals negative b over 2a plus or minus the square root b squared minus 4ac over 2a. But now let me just write it in one fraction. Negative b plus or minus the square root b squared minus 4ac over 2a. Oh my God, that is the quadratic formula. Hang on. So do you see where it comes from? It comes from solving the quadratic equation using completing the square. Isn't that cool? By completing the square, that is what you get. You get the quadratic formula. So that is where it comes from. It's not just some random thing that fell into some guy's lap one time. That's right. That's where the quadratic formula came from, right? And so when you ask, hey, Mrs. Malikian, what is it that mathematicians do all day long? This is what they do, right? They're like, well, wait, if we now use the, completing the square, right? Well, now you can just use this anytime. So listen, you can factor, right? We have like ways to factor. And then if there are equations or quadratic functions that can't be factored, you can complete the square. You can use this method, completing the square, on any quadratic function on the planet. This makes any quadratic function factorable. So there is no more prime. You can always solve it by completing the square. And in the same way, because this comes from completing the square, you can apply the quadratic formula to any quadratic function on the planet and solve using this. All right, so let's solve these using the quadratic formula, right? So if it says using the quadratic formula, I'm looking for the quadratic formula. All right, so let's bring everything to the same side. X squared minus 8x minus 33 is equal to 0. So we know, in this case, right, like A is 1, B is negative 8, C is negative 33, right? So, and then, X is negative B plus or minus, all that stuff. So X is negative B, so it's plus 8, plus or minus the square root of B squared minus 4 times A times C, which is negative 33, so this becomes plus, all over 2A. So this becomes 8 plus or minus the square root of, if you simplify all that, it's 196 all over 2. So 196 is a perfect square. It's actually 14 squared. So this is x equals 8 plus or minus 14 over 2. And so now look, with this, the 8, the 14, and the 2 can all be divided by 2. So this is going to be what? 4 plus or minus 7. So x is 4 plus 7, 11. 4 minus 7, negative 3. All right? Okay. Yeah.
Also, can't we find out if you're able to...
Okay, well, let's do that later, yeah? Okay. So let's take a look at this. So x is negative b plus or minus the square root of b squared minus 4 times a times negative 16 all over 2. So x is negative 6. Yeah, minus 4ac. So negative 6 plus or minus the square root of 36 plus 64 is 100 over 2. So this is negative 6 plus or minus 10 over 2. So look, this 2, you can divide everything by 2. So it becomes negative 3 plus or minus 5. So x is negative 8 and 2. Okay. Here we go. All right, so x equals negative b. So x equals 16 plus or minus the square root of 16 squared is what? 256 minus 4 times 64 all over 2. Yeah. So this becomes x equals 16 plus or minus the square root of 0 all over 2. So this is just 16 over 2, 8. Okay? Okay, here. X equals, oh, I like this one. 4, because it's negative b, plus or minus the square root of 16 minus 4 times a times c 13 all over 2. So 4 plus or minus the square root of, what is this? Negative 36. Ooh, negative all over 2. So this is 4 plus or minus what? 6i over 2. Okay, now again, all 3 of these are divisible by the same number. Divide by 2, divide by 2, divide by 2. So x equals 2 plus or minus 3i, right? So look, all 3 have to be divisible by the same number, and then you have to simplify. If 2 out of the 3 are divisible by the same number, too bad. You leave it the same. You leave it as it is. All right? No, I mean you just leave it the way it is. Okay, so let's take a look at this one. What root 2? Okay, so this one, x equals 8 plus or minus the square root of 64 minus 4 times 9 over 2. So this is what? 8 plus or minus the square root of, what's 64 minus 36 these days? 28 over 2. So this is 8 plus or minus 28 is 2 root 7, right? So x is, again, all these are divisible, so 4 plus or minus root 7. Mm-hmm. No, keep it as a. So here, x equals negative b, so negative 25 plus or minus the square root of, what's 25 squared? 625 minus 4 times 2 times 33 all over 2 times 2 is 4. Okay, x is negative 25 plus or minus, this is the square root of 361 over 4. 361 is a weird one. 361 is actually 19 squared. It's like that emoji, like that shrug emoji, right? It's like, who would have known, right? Yeah. So, yeah, right? So negative 25 plus or minus 19 over 4. And that you can simplify, right? Because you can do this. So it's like x equals negative 25 plus 19 over 4. And then negative 25 minus 19 over 4. So x will be negative 11 and negative 3 over 2. Like you have to actually like do the math. Right?
Wait, would you ever do one of those like a test? Because like I feel like you have to do it, or like it take a while.
Maybe it'll be calculator okay.
Because like
So look, you should know the perfect squares until 16 squared. You should know those. So you should know 15 squared. You should know 16 squared. Okay? That I expect you to know. Anything past that, you don't need to know.
you know what's also like on the shirt after like 2.5 minutes to 15 plus 16.
Yeah. Or you could just know 16 squared is 256.
But then after that, I just
Yeah, after that, yeah. Okay, let's do this one. Oh my god, this one's like one of my favorites.
ooh, that must be a good one.
That's a good one. Okay, so x equals negative 5 plus or minus the square root of of b squared 25 minus 4 times 3 times 4 all over 6. So this is negative 5 plus or minus the square root of, oh, that looks like a negative 23, right? Doesn't that feel like negative 23 to you guys? Right? I know, right? That's the vibes it gives. Over 6. So x equals negative 5 plus or minus what? I root 23 all over 6, but you can't mix those complex numbers. So this is negative 5 over 6 plus or minus I root 23 over 6. Right? Separate them. Okay, don't flip the page yet. Because I like it.
Because, well, no,
You get to separate them. Yeah, you get to separate them. Because it's not your traditional way the numbers look. Okay, you know what? Let's go back to A here. Okay, let's go back to A here. Look at what we got here. Okay, let's look at the radicand. The radicand is the number inside the radical. Let's look at this radicand. I got 196 here, which is a perfect square. And when I got 196, which is a perfect square, what did I get as my answer? I got 2 real solutions. Is that right? Yeah. And those real solutions, are they rational or irrational? Rational. Here too, it's a perfect square, and I got 2 real rational solutions. 0 doesn't really count. Where else did I get that? Here, right? That was a perfect square. And I got 2 real rational solutions, right? Okay. Now look here. When I got 0 as my radical, as my radicand, what type of solution did I get? 1 real solution, right? Yes? But then when I got a negative, then I got what? 2 imaginary solutions, right? Negative, I got 2 imaginary. Okay. Um, huh?
Because
It's plus or minus.
it's x equals 2.
Okay. So then that radicand tells us a lot about the types of solutions we're going to get. Listen, I appreciate you guys working ahead, but you're missing some things I say. It's never, listen, you're going to hear me say this so much. It's never about the final answer. It's always about the process. Okay? Okay? Okay. So, that radicand inside is called the discriminant. It has a special name, the discriminant, and it's b squared minus 4ac, right? So when somebody asks you, hey, what's the discriminant? It's b squared minus 4ac. And let's really learn that name, right? Because we care about, it's called language of the discipline. We care about the technical language. It's not discriminate, it's not discriminatory, it's the discriminant, right? And if you can learn all of the different language of, you know, whatever, Riz and Skibbity and whatever and whatever and whatever, you can learn discriminant, okay? Okay, so it's b squared minus 4ac. So when that discriminant, the value of that discriminant tells us the type and number of roots. So let's talk about when that discriminant is positive. Okay, there are two cases when that discriminant is positive. The first case is when it's a perfect square or when it's not a perfect square. In both cases, you get two real solutions. So when it's a positive, you get two real solutions. But when it's a perfect square, you get two real rational solutions. When it's not a perfect square, you get two real irrational solutions. So on the test and quiz, when I ask you, describe the types of solutions, I don't want anybody to raise their hands and say, can you please tell me what you mean? No, this is when I'm telling you what I mean, right? Okay, so you say two real rational solutions. Now, when the discriminant equals 0, you get one real rational root. When the discriminant is less than 0, you get two complex roots. Okay, now listen. Complex roots. When do we get complex roots? Right. But when we do what to a negative? When we take a square root, right? But where does that square root come from? In here it's plus or minus, right? But where did that plus or minus come from? Here, okay? Remember, it came from completing the square. And remember here, it was because we had a square. And what did we do? We took a square root of both sides. So that always comes from taking a square root of both sides. And when we take a square root of both sides, you always have plus or minus. Is that right? So those complex roots come from square root of both sides plus or minus. That means when you have a complex root, it always comes in pairs. You can never have 1 or 3 or 5 complex roots. It's always 2 or 4 or 6. Always come in pairs. Get it? So that's why it's always 2. So they always come in pairs. Remember that. Okay? Right? Remember that. Whenever somebody tells you something different, you say to them, Mrs. Malikian said, complex roots always come in pairs. You tell them that. Okay? Okay. All right, let's do these and then I'll take some questions.
No, I just have a quick question.
No, hang on.
What was the top one?
Huh?
Two rational?
Okay, I'll go back. Okay, so let's find the value of the discriminant and then describe the number and type of roots. Okay, so the discriminant is going to be b squared minus 4ac. So 64 minus 4ac, that's 64 minus 20, 44. Positive, not a perfect square. So that's going to be 2 real irrational roots. Okay? This one, b squared minus 4ac negative 19. So that's a negative 2 complex roots. And that is that.